Hello, Math 150. We're looking at section 4.5 today, and those are the properties of logarithms. There are several properties that you're going to be tested on and being given homework about, and I want to make sure that you're familiar with them. The first one is one that we've already talked about. We have spent some time talking about how log and exponential functions are inverses as long as they have the same base. So in the three examples you see here, that's exactly what's happening. We've talked about this in the past already. What we've got is a situation where we have a log with a base and an exponential with a base, and those bases match. So when you look here, you've got log base 5 of exponential base 5. They're acting directly on each other. Log base 5, exponential base 5 are going to cancel, and that's going to leave us with 23. Another way to think about this one, if you want to think about this another way that's going to work just as well, is you could say the following. You could take the same expression and you could do that circle idea of how this works. You could say, okay, what does this equal? Well, you know the idea here is we're saying 5 raised to what power equals 5 raised to the 23rd. It's got to be 23. 5 to the 23 equals 5 to the 23. So that's just another way to kind of understand that log and exponential bases are going to cancel when applied directly. In this next example, we reversed it. We've got the exponential function coming first and then the logarithm. But remember, this natural log is really log base e. So we've got the same exponential base as the logarithmic base. They're acting on each other directly. They're going to cancel. We're going to be left with x cubed in this problem. Okay. And in the last example, we see the log base 7 with the exponential base 7. It doesn't matter what the exponent is. They are acting directly on each other. So log base 7 and exponential base 7 are going to cancel. And that's going to leave us with negative 10 in this case. So just kind of reinforcing the idea that logs and exponentials are inverses. As long as they have the same base, they're going to cancel when applied directly. We're now going to take a look at a couple of more logarithmic rules that we're going to run into and you're going to want to be familiar with. The idea here is that logs have certain properties. Now, this could be for any base. I'm going to write them for log base 10, but it could be any base. It doesn't have to just be base 10. And we've got a rule for when you're multiplying inside of a logarithm, and there's a trade-off that's going to happen here. Now, the log of a product, the log of A times B, is equal to the log of the same base of the first part of A, and that's going to turn into addition. So logs turn multiplication into addition, but the trade-off is you go from having one logarithm to two logarithms, and that's the trade-off, okay? I like to say that logs simplify your operations. When you learned about multiplication, you probably learned that it was just a shortcut or a fancy way to do addition. So the more simplistic form of multiplication is addition. Logs take it from the more advanced version to the simpler version. They take multiplication, they turn it into addition. But the trade-off is you go from one log to two. If that makes sense to you, then you can predict what the log of A over B is going to turn out to be. We're going to again have this more sophisticated operation of division, but it's going to turn into the simpler operation of subtraction, but we're going to go from one logarithm to two. So the log of A over B is equal to the log of A minus the log of B, okay? One logarithm to two. Keep in mind that these rules work in both directions. We can turn one logarithm with multiplication into two logarithms with addition, but we could just as easily turn two logarithms with addition into one logarithm with multiplication, okay? It works in both directions. The same is true for the division subtraction one. The last log rule that I want to share with you is the log of A raised to the B. Okay, and that's when that B, that exponent, belongs simply to whatever's inside the log. We could write it like this. Most of the time we don't, but I just want to emphasize that it belongs to the base that's inside the logarithm. When you have this, what we're really going to end up with is what I call the bring down rule. That B can actually come in the front and it becomes B times log A. So that is the third rule of logarithms. It works again in both directions. When we do it in the direction that I showed you, it's called the bring down rule. If we were going to do it in reverse, this would turn into log of A, and then we would actually throw that B back up. So I call that the throw up rule. Kind of gross, but it gets the point across. Okay, that is the throw up rule. It works in both directions. So these are the three log rules that I'm really going to try to stress with you throughout this video today. We're going to look at a bunch of examples, and that's going to get you guys started on your homework. So here's our first two. We've got log base 8 of 2 and log base 8 of 32. They are being added. The addition log rule says as long as we have the same base, and in this case we do, they're both log base 8, we can combine those logarithms into one logarithm of multiplication. So this would actually be 2 times 32. That can be simplified to log base 8 of 64. And when you get to log base 8 of 64, you're asking yourself 8 raised to what power is going to get us 64? That's going to be 2. So this entire expression is going to equal 2, and we can write it that way. In the second example, there is no log base written. Remember, that means we have log base 10. This is the common logarithm. Again, we've got addition, so we can turn this into log of 20 times 500. That's actually going to be the log of 10,000. And now we can play the kind of that circle game, keeping in mind that this is base 10. So we're going to say 10 raised to what power gives us, in this case, 10,000. And that would be 10 raised to the fourth. So we know this answer up here is equal to 4. Two cases of using the addition rule, combining two logarithms to one, addition turns into multiplication. Let's take a look at these next two examples. You see that now I've got two logarithms. They have the same base. So the subtraction rule for logarithm is in effect. We can rewrite this as the log base 5 of 250 over 10. But that will simplify to log base 5 of 25. And now we can ask 5 raised to what power equals 25. That's going to be power of 2. So that's going to be the answer for this top one. For this next one, the same idea. We've got log base 9. We can turn this subtraction of two logarithms into division with one logarithm. That's going to simplify to log base 9 of 81. And now we can ask 9 raised to what power equals 81. That's also going to give us the answer 2. So those are the multiplication and division rules. Again, two logarithms become one. Just want to take a moment to review. I'm sorry, before we review, we're going to do just two more examples. In this next one, what we see multiple logarithms, some of them being added, some being subtracted. So we're going to combine some of these rules. So the first one I'm going to tackle is the addition rule. Again, all log base 4. So this becomes log base 4 of 6 times 10. Still have that log base 4 of 15 trailing along. That's going to be log base 4 of 60. And now minus log base 4 of 15. But now we have the subtraction rule. So we can do two logarithms to one, keep the base the same, and it's going to turn into a division problem. It's going to be 60 over 15. Well, that's going to turn into the log base 4 of 4. And we know that the inverse of a exponential base 4 is a log base 4. You can just look at this and say, hey, those are going to cancel. We're going to end up with 1. Or you could do the circle method of this one, and that would be 4 raised to what power gives me 4 to the first. So that's going to get you 1 either way. So you can combine these rules. You don't have to just do them individually. You can have multiple terms and combine a long string of logarithms into one single logarithm. In this last example we've got, what we have to look at first is we have to look at the exponent first, because that's where we're seeing the logarithms with addition. So we've got two logs with addition. I'm going to do nothing to that 5. It's just going to stay exactly where it is. But up in the exponent, I'm going to make this log base 5. And now I'm going to do 4 times 3 in this case. And that's going to give me the log base 5 of 4 times 3. Exponential base 5 stays the same. We now have log base 5 of 12. And now we're going to make use of the inverse rule of exponentials and logarithms. We've got an exponential base 5 acting directly on log base 5. Those are going to cancel and apply directly. We are going to be left with 12. So let's just recap some of the rules that you guys are responsible for so far. Okay. The first one is if you have a logarithm of any base, if you're taking the log of 1, it's got to equal 0. And again, b raised to what power equals 1? That's the way you want to think about this. B raised to what power equals 1? Well, that's going to be 0 regardless of what the base is. In this situation, if you've got log base b of b, those are going to cancel. Those are inverses. But another way to think about it is b raised to the 1 is going to equal b. So you know this is legitimate. Piggybacking on that is the same thing. This one, b raised to the r, is going to equal b raised to the r. But again, another way of thinking about this is log base b and exponential base b just cancel and leave us with just r. All right, so all these rules are just kind of reinforcing that idea. And this last one, again, this is an inverse version. We've got a log base b right here and an exponential base b. Those will cancel and apply directly. That's going to leave us with just r. Then the last two, which are our newest ones for today, when you have the log of a multiplication problem, it can become multiple logs with addition. So one log with multiplication becomes 2 logs with addition. And then down here, 1 log with division becomes 2 logs with subtraction. The last one that I'll throw in, we didn't talk about it so much in this video, but we'll be looking at the next video. I just want to remind you, if you have log of a raised to the b, that's our bring down rule. That's going to be b times log of a. All right. So I hope this gives you a start on using some of these log rules. The first section of your homework is completely about using these rules. So give that a start and come back and check out the next video when we wrap up or do a little bit more with this section. Okay. Let me know if you have any questions. Reach out as always. Take care, everybody.